A quiet, humid afternoon can turn into a towering thunderstorm when the air above us is ready to rise. The cloud that does the heavy lifting is cumulonimbus, the deep storm cloud behind thunder, lightning, hail, heavy rain, and damaging wind gusts. The basic recipe is simple: moisture, instability, and a trigger to lift the air. Warm, humid air near the ground is less dense than cooler air above it, so if it is pushed upward, it can keep rising. On many Australian storm days, sunlight heats the land through the morning and early afternoon. The ground warms the air above it, the boundary layer mixes, and small puffy cumulus clouds may begin to appear, but warmth alone is not enough. The lower atmosphere also needs water vapor because that moisture will feed the cloud once the rising air cools. As the parcel of air rises, the air pressure around it falls. The parcel expands and cools without exchanging heat with its surroundings, a process called adiabatic cooling. When it cools to the dew point, water vapor condenses into tiny cloud droplets. Condensation releases latent heat, which slows the cooling of the rising air. That extra heat helps the parcel stay buoyant, so the updraft can keep building the cloud higher and higher. This is deep moist convection, the engine inside a cumulonimbus cloud. If the atmosphere is unstable, the rising air remains warmer than the air around it, and the tower grows quickly. If the atmosphere is stable, the rising motion weakens, and the cloud may stay shallow. A trigger is often the final push. Around Australia, that lift can come from sea breeze fronts, cold fronts, hills and ranges, or convergence lines where winds meet. Along the coast, a sea breeze can move inland during the afternoon, forcing hot, humid air upward and sparking storms well away from the shoreline. As the storm grows, it usually passes through three broad stages. In the cumulus stage, updrafts dominate, and the cloud rises like a white tower with a flat base. In the mature stage, updrafts and downdrafts work at the same time. And this is when heavy rain, lightning, hail, and strong gusts are most likely. In the dissipating stage, downdrafts cut off the warm inflow, the rain weakens, and the cloud loses depth. The top of the storm is shaped by the tropopause, the stable layer near the top of the troposphere. When the updraft reaches that lid, it cannot keep rising straight up, so the cloud spreads sideways into the classic anvil top. Upper winds can carry that anvil downwind, away from the heaviest rain core. Wind shear can make the storm more organized. Vertical wind shear means wind speed or direction changes with height. Strong shear can separate the updraft from the rain and hail core, allowing the storm to last longer. When strong instability and strong shear combine, a rotating supercell can form, and that is one of the most severe thunderstorm types. Hail forms inside strong cumulonimbus clouds when updrafts lift droplets into cold parts of the cloud. The droplets freeze, collect more ice and water, and grow in layers until they are too heavy for the updraft to hold. Some cumulonimbus updrafts can exceed 161 km per hour, which shows why these clouds build so fast and why aircraft avoid them. For safety, watch Bureau of Meteorology thunderstorm warnings, especially on hot, humid days, with a clear lifting trigger. Move indoors early, secure loose items, and stay away from trees and power lines during severe gusts. The next time a small cumulus tower starts climbing, remember the recipe: moisture, instability, lift, condensation, latent heat, and a powerful updraft reaching for the tropopause.